Today we're going to talk about valence electrons and Lewis dot. Already in this unit, we've covered on valence electrons a little bit and charges, but now we're going to cover them in detail, and Lewis dot is how to represent them in visual format. So we're going to cover these two things today. So valence electrons are the outermost electrons in a shell. So it's not the total amount of electrons, it's the outermost electrons, and they determine the chemical physical properties. They're defined as the electrons in the atom's outermost orbitals. When we are talking about the sharing or taking or giving of electrons, we are talking about the valence electrons. We are not talking about all the electrons. We are consistently only talking about the valence electrons when we're talking about taking, sharing, giving. You want your valence shells, your outermost shells, to mimic that of a noble gas in order to reach noble gas formation. Now, we're not exactly sure how to do that yet, and that is okay. That is another unit, but I want everyone to realize valence electrons are specifically a specific subset of electrons. I'm going to show you the periodic table trick, but if you just want to memorize them and you do need to know these, know that column 1 has 1 valence electron. Column 2 has 2 valence electrons. Column 13 has 3 valence electrons. Column 14 has 4 valence electrons. Column 15 has 5 valence electrons. Column 16 has 6 valence electrons. Column 17 has 7 valence electrons, and column 18 has 8 valence electrons, unless it's helium, which has 2 valence electrons. So when we're talking about the periodic table trick, it's super easy when you're just looking at the periodic table. And this trick is specifically for representative elements. Please remember, for your transition metals, you have to be told how many valence electrons they have or their charges. So when we're looking at the periodic table, you just number your representative elements from 1 to 8, and that is your valence electrons. So you have 1 for column 1, 2 for column 2, 3 for column 13, but it's the third representative element column, 4 for column 14, because it's the fourth representative element column, 5 for column 15, because it's the fifth representative element column, 6 for column 16, because it's the sixth representative element column, and 7 for column 17, because it's the seventh representative column. Column 18 for neon through 118, it is 8 valence electrons, and helium has 2. So we talked about valence electrons. Let's talk about how to represent that in a visual format. So we're going to make a Lewis dot. Lewis dot is the visual representation of the valence electrons for an element. And these electrons are represented by dots. For Lewis dots, the dots must be flat against the side of the element, not sticking out. Dots that stick out mean they're ready to bond. Dots that are flat against show that they are valence electrons belonging to that element. I made up a fake element called EL in order to show you the dot placements. This is just a fake element. Please see that on the actual elements, the actual elemental symbols. Don't just use L. This is just a made up element to explain it to you. There's a specific dot order in how you fill in the dots. the dot order is right, left, up, down, and then you start again. Right, left, up, down. And you're always going to do 1 dot per side filling in. The only exception to that is helium, which has 2 dots on its right-hand side to show that it is already a full orbital. So here how it goes. Here's my fake element L. The first thing we're going to do is put in 1 dot. This 1 dot represents the electron configuration for all alkali metals, or all of column 1. Let's do the next dot. This second dot with 1 on the right and 1 on the left is the Lewis dot representation for all alkaline earth metals, or column 2. Let's do our third dot. We have 1 to the right, 1 to the left, and 1 on top. This dot formation is the formation for Lewis dots for all of the boron family, or column 13. Let's do a 4th dot. Now we have 1 to the right, 1 to the left, 1 to the top, and 1 to the bottom. This dot formation is the Lewis dot representation for all elements in the carbon family, or column 14. Let's do our 5th dot. Look, we do it flat against. So you have 2 dots on the right-hand side, 1 dot lone on the left, 1 dot lone on the right, 1 dot lone on the bottom. Please notice that they are flush against the atomic symbol of the element. And this Lewis dot formation, this Lewis dot representation, is the representation for all members of the nitrogen family, or column 15. You do 1 more to the left, because remember you go right, left, up, down. So let's do our 6th dot, right, left, up, down. So this dot here with 2 flush to the right, 2 flush to the left, 1 lone on the top and 1 lone on the bottom is the Lewis dot representation for all members of the oxygen family, or column 16. Please note that these are not sticking out. They are flush right up and down against the atomic symbol. If you put them sticking out, that will be considered incorrect, because sticking out dots means something different in chemistry. We're adding a 7th dot now. So you have 2 flush to the right, 2 flush to the left, 2 flush on top, and 1 alone on the bottom. This is the Lewis dot representation for all members of the fluorine family, also known as the halogen family, also known as column 17. And finally, we're going to add our 8th dot, and notice that it is 2 dots on each side, completely flush, and this is the Lewis dot representation for column 18, or noble gases. The only exception on column 18, or noble gases, is helium. Because remember, helium has 2 dots on its side, showing that it has a completed orbital. So let's look at this a different way, because remember I said these Lewis dot representations were for every member of the family. So if we're going to look at it as in a periodic table, please note the valence dots, how I did it for all members of the family. Remember, helium has 2. Remember, the green is the S block, the light green is a P block, the pink is the D block, and the F block is yellow down here. We do not do the we do not do Lewis dots or memorize valence electrons for the D or F block. The column numbers are in pink and the valence electrons are in green. Are there any questions? Let's remember the charge of each column that you're supposed to memorize. I'm going to put it, I'm going to put it up here. Column 1 is 1 plus. How do I make it? There. Sorry, working on it. Column 1 is 1 plus. Column 2 is 2 plus. Column 13 is 3 plus. That wasn't very good. Sorry, guys. Column 14 we don't worry about because the ones are on here will act as transition metals. So you have to be given the charge. Column 15 is 3 minus. Column 16 is 2 minus. Column 17 is 1 minus. The transition metals must be provided charge due to multiple oxidation states. Okay, those are the electron, the valence electrons, the Lewis dot, the blocks, the elements. Down here, the elements are more up to date on your periodic tables, and the charges you really do need to know for this unit. Please do not forget that on each page for each block, there's a breakdown of charges and valence electrons and family names as well.